computers in all areas of the business. We use state-of-the-art computer modeling for all design work. Here you see three-dimensional renderings for the 26. These boats are designed on the computer, and full-size drawings and cross-sections are plotted to create the master shapes for our molds. This is fiberglass roving. It provides the basic strength of the laminates. It'll take loads of 35,000 pounds per square inch. This fabric has all the strands going in one direction. It's used for local reinforcement. This is fiberglass mat. It's made of short fiberglass filaments. It holds a lot of resin and provides stiffness and rigidity. This is fiberglass cloth, also made up of long filaments of fiberglass. The fabrics are cut to exact patterns. A stack of 20 boats worth is cut in a single pass. We start with a highly polished and waxed 3-ton hull mold. The boat is built from the outside in, starting with the white exterior gel coat. The areas for black accent stripes are masked off. The boat's finish will be as good as the surface of the mold. This gun sprays both catalyst and gel coat. The catalyst causes the gel coat to harden and cure. Gel coat is a pigmented polyester resin. While the gel coat's wet, the masking is removed, leaving a window for the black color. Black is then sprayed to form the stripes. The entire surface is covered so that any trapped air will be visible during the layup process. After the surface cures, a layer of fiberglass mat is laid on the mold. Polyester resin is then sprayed onto the first layer of mat. The guns provide an exact mixture of resin and catalyst. Fiberglass cloth is then placed over the mat. Rollers, squeegees, and brushes are used to remove any air bubbles and excess resin from the laminate. This is where the real quality of the boat is determined. Additional layers of mat and roving are applied. This is hand layup, the strongest and most easily controlled method of construction. In some areas of the hull, there are as many as 15 individual layers of fiberglass. Other builders use chopper guns, which spray resin in short strands of fiberglass. We don't use them because they yield weak, heavy, and brittle laminates. Thickness will vary depending on the loads at each location. At high load areas, the finished laminate will be approximately 5/8 of an inch thick. This is the nearly finished hull. You can see the molded-in water ballast tank. With the hull still in its mold, the liner is bonded in place, forming the complete hull assembly. After the resin hardens, the hull is removed from the mold. Notice the molded-in stripes and the brilliant gloss on the exterior. The hull liner mold has just been sprayed white. This is the finished hull liner before it's removed from the mold. And this is the hull liner after it's been removed. It's built like the hull, only not quite as heavy. This is the deck mold. The non-skid texture is formed into its surface. The black areas around the windows are masked off, and the deck is sprayed with white gel coat. The masking is removed very carefully before the white is cured. Black is then sprayed to cover the window area and make it easy to spot air bubbles during the layup process. The first layer of mat's laid down and wet out with resin. This is the finished mat. The balsa core material is pressed into a layer of wet mat. After the bond cures, another layer goes over the top. There are cutouts in the balsa everywhere hardware will be located. Many layers of mat and roving are added wherever hardware is bolted or wherever there's high concentrations of stress. The completed deck is lifted from the mold. Notice the non-skid pattern and the black areas surrounding the windows. No further work needs to be done on the outside surface finish. It even comes out of the mold waxed. This is the deck liner, which provides structure and a waterproof high-gloss surface for the inside. Here are a few of the molds that make up the rudder, centerboard, hatches, bulkheads, and other small parts. This large template router makes a perfect